Okay, so in this question, what we're told to do is from David Anderson's book. I've taken off the question and I'm going to do complete the plan elevation of the roof surface. We're told that the angles C and D have a pitch of 50 degrees, surfaces A and B. Surfaces A has a pitch of 70, B has a pitch of 40, and E has a pitch of 60. And then the second part of the question is develop the surfaces A and C. Now, as you can remember from what I was talking about roof pitches, the pitch of roofs as a key principle, all I'm simply done is I've projected my auxiliary of D and C out here so that we're told it's pitched at 50 degrees and we'll see the two surfaces as an edge view. This will give us the true height of our whole surface, which we can bring up into elevation and we can find our true height. Then we're told we can see surface E at 60 degrees, so we know that we'll see surface E as an edge view in elevation. So all we simply do is draw our 60-degree line from where E meets the XY line, and we get the height and we get the edge view of surface E. Same again for surface A. We're going to project it up at 70 degrees to where it meets this height and bring it back down, and that's where we get the apex of surface A here. But then we also know that surface B will also meet surface A. So what we need to do is we need to come up from where this point here in plan, 40 degrees up, bring it back down, and we get our true shape of surface B and not true shape, our plan view of surface B, plan view of surface A, D, C, and E, right? So that's the first section completed. Now, what I really want to focus on in this question isn't so much the plan and elevation, because we covered that topic in a previous principle. We're covering now the topic of developments. So when we talk about developments, what we're really talking about is flattening out the surface to see the true shape of the surface. So developments, when you're being asked in a Leaving Cert question, what you really think of is true shape. Now, there's two ways of finding the true shape of a surface. There's an auxiliary view, or there's using rebatment. Now, from what I can gather, most students are very confident in understanding what they're doing when they're using auxiliary views. However, when we're looking at rebatments, students seem to be able to confused around what's actually occurring. So what we need to do is we're trying to find, in the first one, is develop the surfaces A and C. So first of all, what I'm going to do is I'm going to develop surface A. Now, in order for rebatments, what we need is an edge view, of a surface. So if I was to look at surface A, what we're given our edge view of the surface, right? Now, what I'm going to do is I'm going to bring in my completed development. I'm going to explain what's going on as best I can. Okay, so as you can see now, right, what we've done is we have completed our development of surface A, giving us the true shape of surface A. Up in elevation, you can see that I have just used my compass and swung arcs from the heights of the point from this point here, because that's the point that lies on the ground. So when we're looking in plan, we'll have to see that this point here is a true length line. So what we see then is what I've got is the best explanation that I can find if I was teaching this in a school would be to use a hinge, right? So the hinge of a door, the hinge of a window. I've just got hinges here. I bought hinges and they're very straightforward. All I'm doing is I want to explain that when we're looking directly on top of it, we're getting our surface and we're rotating it until it lies flat on the ground in elevation. So that's what we're simply doing. We're just rotating our surface like I am here, represented an arc, rotate, 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 and it's lying flat in elevation. And when we bring our points down into plan, we use these as our heights for our surface because our heights are given in the question. And what we do then is we project off using this and we will get the true shape of surface A, or the development of surface A. But what I am to emphasize is this is the true shape of surface A. Okay, so we've just completed the development of surface A. And now in the second part of the question, we're told to develop the surface C. Okay, So surface A, we can see now that we were given surface A as an edge view. Now, at the very beginning of the question, the importance I highlighted was we found surface C as an edge view. Now, we rotated our heights off of it in plan. What we technically are doing is this auxiliary view is giving us these two surfaces as an edge view, which means we're looking directly along the surfaces. And I'll use the hinge again even. We're looking at it like this. So surface C and surface D. We're getting the pitches of these, right? And that'll give us the true height of surfaces C and D. Now, again, what I'm going to do is I've got this already completed using tracing paper, which I found was very helpful. So what I've done is I'm going to just line it up as best I can. Exactly the same as what we did up on the top. Instead of using the edge view in elevation, because that would be our edge view in elevation, we don't have an edge view of these surfaces. What we're going to do is we're going to use the edge view in our auxiliary view as our hinge. And we know for a fact that this point here is going to be our hinge point. So what we're going to do again is we're going to get our hinges, line it up, and hinge it off until it reaches our x1, y1, like that. And where it reaches our x1, y1 down here, we're going to bring it across. We're going to bring it down from where they hit the point. So we know that this line here, we have to bring it across then all our points until they hit the edge view of our surface. We'll rotate them around and we'll bring them down. And when we bring this point down, we're going to get the development of surface C, or the true shape of surface C.